As we shown the previous video, we already known about the scheduling algorithms, and these are all the types of scheduling algorithms, which is FCFS scheduling. For disadvantage of FCFS scheduling, to overcome the next to overcome that disadvantage, we have to move to the next shortest job first scheduling. In this also we can have some disadvantage. To overcome that, we have to move on this priority scheduling. In this priority scheduling also we have seen some disadvantage. To overcome that disadvantage, we have moved to the round robin scheduling. So each and every scheduling algorithms can have many advantages and one few disadvantages. To overcome that particular disadvantages, we can find out the new algorithm for rectify that disadvantage. For recently we can use the recent scheduling, in the sense multi-level feedback queue scheduling, multi-level queue scheduling, round robin scheduling we have recently used by latest technology in OS. So we'll see the next thing. Then we can see the elaborate session about FCFS scheduling algorithm. First, new process is added at the tail of linked list. There should be some Gantt chart for making the process states and burst time and turnaround time, waiting time clearly. So each and every process, it should be added in the linked list box, which is nothing but Gantt chart. So if a new process is entered, it should be added at the tail of the chart, and first process which should be presented in the chart is requested the CPU, which is called FCFS. Which process came to the first in this chart, it can only eligible to request the CPU first. So once it got the CPU to execute the process, it's moved to the running state. Once it completely execute that particular process, it's move to the exit state, which is release state, or it needs some input output or event wait input output resources, or event wait means it just went to the waiting state. Once it's moved to the waiting state, it wants CPU, means it's gone back to the linked list Gantt chart. So once it IO request or even completion is fixed, then it's again requested the CPU for running that particular process, and once it's done, it released. So this is the FCFS scheduling algorithm. And next is shortest job first scheduling algorithm. In this shortest job first scheduling algorithm, process and burst time was presented in the some kind of table, and also we have already seen about the Gantt chart, which is having the process details and number of process. So in this process, P1, P2, P3, P4 or 4 processes are there, and each and every process have some burst time. Once which process can have the low burst time, that process only can request the CPU first. So here P4 can have the very low burst time, so that P4 can eligible to request a CPU first. So once P4 process is done, then we can the next process, the rest of the process are P1, P2, P3. In these three processor, P1 can have the low burst time. Then second process P1 is eligible to request the CPU. So then move to the P3 and move to the P2. These are all the priorities which can be used in shortest job first scheduling algorithms. In this means process P1 gets executed second, as it has the burst time of 6, which is larger than P4 but shorter than P2 and P3. So in this case, P1 is already entered, which has the 0th arrival time. So P1 is finished, then move to the then comparatively P4 is low burst time, comparatively P2 and P3, then P4 is executed, then P3 is executed, then P4 is executed. Based on this we can calculate the waiting time and turnaround time. Thank you.